The carbon dots, little carbon nanoparticles, can have different colors, beautiful colors. There is a good reason for these colors that we can do magic with them. For example, we can take the carbon dots, use the color to image cells and vesicles. You see these beautiful colors you can get from labeling using these carbon dots. Label these vesicles and get different colors. The carbon actually is a member of honor of the nanotechnology world. We can get different carbon nanostructures, pure carbon nanostructures. The first one that was discovered about 40 or 50 years ago, and somebody got the Nobel Prize for that, is called C60 or fullerene. Just like a ball, football. In India you say soccer or football? Football? Like this, yes? Okay, so this is the football. This is a nano football made of just carbon. Pure carbon organized in a very symmetrical way. Very interesting chemical and physical properties of this nanostructure, which is called fullerene. For example, you can use fullerene and make a transistor. This is the fullerene. This is one electrode, two electrode. When the fullerene is there, you can get different currents going through. This is a transistor. You can use fullerene as a lubricant, just like oil. Put the fullerene between two layers of material, and it will be smooth surface, just like a lubricant. And of course, there's various variations of this fullerene. Now, we saw many different things and interesting things about nanostructures and nanomaterials and nanotechnologies. Now, one important question that you can ask, okay, it's very interesting. Can you make money out of this? Making money is very important in life. It's not the most important, but it's also important. So what I'll show you now are a couple of slides with actual products and companies that people made over the years from nanostructures. So for example, here we have artificial cartilage. You know, sometimes you get problem with your knees. You have to replace your knees or replace the cartilage in your knee because it's just like very bad. So artificial cartilage, that's an actual product that you can not buy, that doctors can buy and put in your knee, is made from nanoparticles. And again, as I showed you these lubricating properties, this is what you can do with them. You can get various composite materials from nanoparticles and nanomaterials. For example, airplanes now. You can build lighter airplanes from nanomaterials. This is a nanogel. This is actually a sunscreen or a cream that you can make from nanoparticles. Because you have nanoparticles, we're going to talk about it, they can penetrate very easily through your skin and then protect your skin or serve as a medicine. Solar cells now, we're going to talk towards the end of the week about nanotechnology and solar energy. Now you can make giant solar cells. This is very big. This is not nano. This is macro. But these materials, when you look inside, they are made from nanomaterials. So, you can make money. That's good. That means that you should listen very carefully to this class, this is a course, because at the end you might know how to, maybe you have some ideas about how to make new products using nanotechnology. Now, what's the future? What's the future of nanotechnology in general? Okay, so one thing about the future is that you cannot predict the future. The wisest people on earth have difficulties predicting what's going to happen next week, next month, next year. This is exactly the case with nanotechnology. For example, you remember this guy, Richard Feynman, the guy that we talked about in the first slide or so? In his book, remember, it's all started from this book that he said, there's plenty of room at the bottom. So in his book, Feynman wrote 2 challenges. He said, if people ever can do these challenges, then the world of nanotechnology will be here. And these are the 2 challenges. He actually thought that these challenges, maybe it will take 50 years to do. But let's see what happened. The first challenge that Richard Feynman wrote in his book was, if it will be possible to build a motor that will be so small, 1/64 of an inch. This is like 10 micron motor. Very, very small. When Feynman wrote his book, it was something totally unbelievable, unimaginable. But he wrote it in 1960. In the same year, some people succeeded to do that. It gives you an idea about the human ingenuity, the human innovation. He set another challenge. He said, what will happen if it will ever happen that you can write the entire Encyclopedia Britannica. You know Encyclopedia Britannica? Well, nobody's reading encyclopedia these days. Encyclopedia Britannica is not one book. It's about 100 books, each one 1,000 pages, and it basically describes everything that there is on Earth, geography, history, art, everything. 1,000 books, 100 books. 1,000 pages, 100 books. And the challenge was, let's put all of the Encyclopedia Britannica on the head of a little pin. If you succeed to do that, this is going to be nanotechnology. Now, he made the challenge in 1960. In 1985, people used a technique called electron beam lithography, and they succeeded to write the Encyclopedia Britannica on a pin. You can see one page of the encyclopedia. So we can do anything we want, almost. So this is one prediction of the future. This is actually, I took from an article that appeared in about 1998. It's an old article. This article talks about how chips are going to get smaller and smaller. So this is according to the prediction. These days, you can actually get chips that are here. The capability to make smaller and smaller chips, remember the nanowires I showed you? Using that, you can make now chips that will be based on quantum phenomena that will be extremely, extremely small and fast. Nanotechnology patents. You see, there's more and more patents, more new things invented. Right now, this is 2005, 10,000 patents about nanotechnology a year. I'm sure now we reach maybe 100,000 or million patents a year. So to conclude, it's too early. I need to talk another 15 minutes. I'm joking. So what did we learn in these 2 lectures? We learned that nanoscale materials exhibit very interesting properties, distinct chemical and physical properties. We see that nanotechnology has an impact in diverse fields, in chemistry, in engineering, in biology. You know what? Even in art. But we're not going to talk about it here. There are new scientific, technological, and commercial applications. And that's it. That's it for the introduction. Questions? Yes? Thank you. From what?
From knee pain.
Ah, knee pain. Okay, yes. I'm sorry for her, yeah.
You told about artificial cartilage.
Yes.
So I wanted to know that, is it in use? And if yes, how prevalent it is? And will it ever come to India?
Well, you know, I don't know the details, but I'm sure if you search in the internet, there is a lot of, it's called artificial cartilage. Some of the artificial cartilage that they sell as products are made of nanoparticles and nanomaterials. In many cases, the companies that make it, they're not telling you what it is, because it's like a trade secret. They make it in their labs. They don't want anybody to know, so they're not going to have competition. But it is made of nanomaterials. So what I suggest to you, or to your doctor, or to your grandmother's doctor, if you can just search for products in the internet, or type keywords, artificial cartilage nanomaterials, and you'll find various products. Good luck to her. Okay, everybody. No more questions. So we'll see you tomorrow. Yes, sorry. Yes. Okay, DNA chips. So we have a few minutes. I'll talk some more. In many cases, when you have genetic diseases, to find out the actual disease, what you need to do, you have to find which genes are defective, which genes have problems. Now, you know, in our body, in your cells, there are thousands of genes. So how will you find what is the bad gene? How will you find what genetic disease do you have? So what people do, actually, let me just go quickly here. What people do, or what not people, what the companies do, they take this chip, and in each well here, they put a little sequence of oligonucleotide. You know, oligonucleotide, these are the building blocks of DNA. Each of the oligonucleotides here is different, and each one recognizes a different gene. Each one will bind a different gene. So what do you do? You have here maybe 1,000 markers, binders for specific genes. And then you take a drop of blood And you put a drop of blood here, and you shake a little, and the genes that are defective, because each well can target a different gene or different defective gene, the genes that are bad will bind to the different wells, and you look under the microscope. It's not a microscope, you have a camera, a very fast camera, and you will find here there's binding, here there's binding, here there's binding. If you see this binding, maybe you have cystic fibrosis. If you have here, here, and here, you have another disease. Sometimes you can use this for detecting cancer, for example. And you could do that only because you made these wells so small, nanoscale cells, that you can, in one chip, you can screen for thousands of genes in 1 minute. This is the idea about DNA nanochips. Okay? Very nice. So, see you tomorrow.